Hello, Design Systems friends. How are we doing out there? I had to wait till that song was ended right on the perfect beat. Y'all were enjoying that playlist so much. I really wanted to make sure you got the end of that phrase. Just kidding. I am so excited to introduce our next talk. Um, if you didn't know his name before the conference, you've heard it a few times now. You probably know Nate Baldwin as a color enthusiast, a tokens expert, and the creator of some amazing tools, including Leonardo and Proportio, which have been mentioned a couple of times already during the conference. Nate, are you with us?
Hello, yes, I am.
How are you doing today?
I'm doing great.
How are
Glad to
you
be.
feeling? How are you feeling after 3 days of design systems excellence?
My head is exploding. It just keeps getting filled with more and more ideas, and I've been loving this conference so far. So,
Oh, amazing. We're so excited to have you. For folks who don't know, I learned when I was chatting with Nate, getting ready for the conference, that he spent almost a decade in design systems, but maybe not surprised to find out that you started as an illustrator and you studied fine arts. Can you tell us a little bit about how you got into design systems from Illustrator to where you are today, coding these epic tools?
yeah, it's a weird journey. My big career plan was to be a fine artist and to be an illustrator as a way of making supplementary income. I failed to realize that both of those were very difficult to make a living doing. Um, And I started kind of inching my way in this direction by any time I needed to make an update to my portfolio. I had this terrible table-based website, and whenever I had a new show or I had new work, I didn't know anyone who could help me. So I was like diving in on a notepad with unformatted text and trying to figure out how to update it. Needless to say, after a while, I just kind of fell in love with it and uh, made my way into graphic design. So I worked for a company that as the in-house graphic designer, the only graphic designer, and I had to support multiple vendors and freelancers to create cross-platform, cross-media marketing campaigns. And so that really got me into design systems was like I started creating templates and brand guidelines, reusable assets, trying to formalize these approaches where I could share assets with people that I was probably never going to talk to and have some degree of confidence that they would be able to produce creative materials that looked on brand and met kind of the campaigns we were creating. Um, and yeah, then I just saw like the digital realm has so much possibilities for like systems and really automating those kinds of processes. So transitioned into that realm and the rest is kind of history.
I love that. So even an illustrator studying fine art can fall in love with the technical side of all things where art and technology collide, which is amazing. And thankfully you did, because now we have so many cool tools that save the rest of us from having to learn to code. So thank you on behalf of all of us for doing what you do. Before we dive into your talk, I have three questions to ask you, if you don't mind.
Mhm. Yep.
Okay. You as a person are symbolized as an emoji. What would your emoji be?
I think I'd be the melting smiley face. I kind of see that as the emoji version of the dog drinking his coffee with the fire in the background saying everything's fine. That's kind of me.
I feel like next year the stickers might say team good enough and they'll have the melty smiley face on the side of them. Sounds epic.
I
Okay,
love it.
great. Okay, second question. What is the component that you love to hate to work on?
Hmm. I hate cards. I can't stand them. I should like I should like them, but I don't. They're the different ways that you can format them, or it just it annoys me. And all the problems that you come into about responsiveness and fitting them into a grid, and how should they transition between a table to a grid view. I hate it. So yeah,
I love
cards.
that because I actually think that documenting a color palette is kind of like creating a tiny card. So every time I have to do it now, I'm going to think of you with all the love in my heart.
Perfect.
Okay, third question, very most important one. You get to order the perfect pizza. What are
Hmm.
your toppings of choice?
Yeah, I think I have to start with the base before we get to the toppings. It's
Mm.
got to be a New York style pizza. Got to
Okay,
be big slices,
mm,
thin, thinner crust. I got to be able to fold it. So there's that. And then all the meats, pepperoni, Italian sausage, ham, bacon, all of it.
oh, sounds delightful. I'm with you. I'm with you on the folding of the pizza. I'm here for it. Amazing. Well, you guys are in for it today. So, Nate's actually going to share with us this story about this challenge that he was going through with a system he was working on, and all of the, and like designer trigger warning here, code and math and GitHubness that had to happen there in order to solve the problem for all of us so that we don't have to do that. And Nate has already provided links to the slides, as well as a link to a GitHub, a sandbox, and a no code version of this demo tool that you've built specifically for this presentation, which is so grateful and accommodating. When we were having our chat before the conference, I had said to Nate, he said, there's a GitHub link at the end where you can see the project. And I said, but do you know that designers get GitHub face? And he said, well, what's that? And I said, well, you ask a designer to go into GitHub and they do this. So he was so grateful to give us a version of that, that us who get the GitHub face can actually go in and access. So with that, I will let Nate take it away and introduce himself and onto this epic presentation.
All right. So let me see here. Let me know if you're not seeing my title screen.
It looks beautiful.
Perfect. All right. Well, thank you, Sam, for the introduction. If you can't tell, I am having a little bit of fun with my title. Right. Everything in design systems is about scale. Something's either on a scale, it is a scale, it's made to scale, or it is at scale. So, hey, why not have some fun? But in reality, I am going to talk about how to make scalable scales that scale. And what I mean by this facetious little phrase is creating multidimensional, multi-level, and adaptive systems for design. These are systems that can help you to create adaptive and responsive typography, responsive spacing, proportional design foundations that support various unique component designs, and a system for size and density options across components. And a complex example of this started with a story from about a year ago. So my team at Intuit got a simple request from our marketing team to enhance our button component. The button sizes that we had were not large enough for their use cases, so they wanted some larger buttons in our system. Until then, the button sizes we supported were 24, 36, and 48 pixels tall. Our design system followed an 8-pixel grid system, so the next size options would reasonably grow by 8 pixels in height from the previous size. This approach gave us 56 and 64 pixel height options for our buttons. For these new button sizes, the text also increased in size. So each size followed the values of our type scale, which was a consistent approach that we used for other sized components. But then things got a little hairy. The marketing team wanted the text size to actually stay the same across the medium and all these larger sized buttons. And this deviated from the conventions that our team was using for handling sizes in components. So we needed to be consistent with our system, but we also needed to support this marketing request. As a result, we created 2 new button sizes, plus a whole new button component specifically for marketing. The product button sizes followed our type scale, whereas the marketing buttons had the fixed text size that they requested. What began as a simple request became a point of fragmentation by introducing duplicate button components into our design system. So the solution itself became a part of the problem. And the situation was growing more complex. Some teams were eager to use responsive scaling in our products. As the viewport size changed, teams wanted their product's text and spacing sizes to change along with it to provide optimal user experiences. Other teams wanted to implement rem-based values in order to support accessible text scaling on the web. Rem stands for root M size, which is essentially like a percentage of the default browser text size of 16 pixels. As users change their default browser text size, all rem-based sizes will change along with it. But until now, all of our text size values were in pixels. This was a complex problem for our team. It's an example of a systematic problem with size and spacing in a design system. And it's a problem that I don't think is too uncommon. The challenge was, how might we create a system for size and space that's visually balanced, scalable, and adaptive to support responsive design, component options, personalization, and accessibility. So I'm going to take a look at this problem from the ground up. I'll use some example code and demonstrations from a coded prototype that I'm going to share after the talk. And along the way, we'll uncover a few systems-oriented design methods that will help us to solve this and many other systems-related problems in the future. Typically, as designers, we begin any size or space-related exercise by using a pixel grid system. Every unit of measurement conforms to the basic rule that the value must be divisible by this number. So a common example of this is an 8-pixel grid system, which gives us numbers like 8, 16, 32, and so on. This sequence of numbers is called a linear progression. Every value has a common difference of 8 pixels, which can be expressed as y equals x times 8. As designers, we're naturally drawn to this approach for its simplicity, and because we're usually looking for balance and symmetry in design. These numbers seem to provide us with that, at least at first glance. But evaluating the common difference of 8 pixels focuses on an absolute difference. One value minus its previous will always equal 8, regardless of the number. With a linear progression like this, small values will have a large difference between them, whereas large values will have a small difference. For example, the difference between 8 and 16 pixels is 100%, whereas the difference between 96 and 104 is only 9%. This makes it difficult to create and maintain spatial relationships with a linear scale, as the values themselves are out of proportion. The values of a linear scale grow at an exponentially decreasing rate. This becomes a usability issue for product teams because the choice between spacing with 64 versus 72 pixels is unclear. Both of these sizes appear very similar in the context of design, and in some cases, the differences are nearly imperceivable. As we look at how these values apply to component design, we come across another problem. Should the height of the component or should its internal spacing conform to the pixel grid? It's rare that you can have both the height and the internal spacing conform to the grid. And in order to create designs that are visually balanced and proportional, you typically have to deviate from this approach on a case-by-case basis. Sometimes only the height conforms to the grid, and sometimes only the padding conforms to the grid. As you grow to support more component sizes and options, the problem only gets worse. So the fact of the matter is, to put it quite bluntly, pixel grids are crap. Any rule that requires inconsistent application of the rule in order for that rule to be followed is not systematic. Subjective inconsistency does not scale, and absolute difference in spacing values gives inconsistent relative differences, which results in unproportional sizes and difficulty using the system. Pixel grids aren't proportional, they're not flexible, and frankly should not be used in a design system. So for these reasons, we are going to ditch the grid. Now, if we're not starting with a grid system, where should we begin? Well, we need to start by breaking down the problem. First, we need to identify some key relationships in our system and which ones need to be adaptive. We're going to illustrate these relationships to help clarify each part of the system. Identifying these at the beginning is going to help us to solve a complex problem one piece at a time. The first topic we can address is that of responsive design, or the relationship between the viewport size, text, and spacing. We know from our problem statement that we're going to want both the text and the spacing sizes to change based on viewport width. Headings for mobile screens will need to be relatively small, whereas headings for widescreen displays will need to be relatively large. In smaller screens, we may want to have denser layouts compared to wider screens, which may benefit from having more spacious layouts. Altogether, this will help to create content hierarchy and spatial relationships while respecting the available screen real estate. The next relationship is that of extensibility, or the ability to add new features or functionality to the system. For example, we know that we need to support different component sizes and densities. Some components in our system will be small and some will be large. Some will use small internal spacing and some will use larger internal spacing. There are some components that will need to support options for sizes, and there are other components that will need options for densities. Our system needs to support all of these different use cases for size and spacing in our components. And the final relationship is that of personalization and accessibility, or the relationship between our product and our end user's personal needs. All text sizes must change based on the user's preferred text size. So as users change their settings, our entire system needs to adapt to fit their needs. Looking at these three topics in our problem statement, we can begin to illustrate the various parts. We can see how viewport widths need to affect spacing and text sizes, that component size and density options are directly related to internal component spacing and the component's text size. And we can see that user-preferred text size will need to affect all text sizes. For complex systems problems, breaking them down into smaller parts is called encapsulation. This approach separates problems and relationships of a larger system. In development terms, it's also known as a separation of concerns. Using this method can help us to effectively solve each problem independently. And when we put these smaller relationship diagrams together, we can see a more complex system emerge. By highlighting the smaller encapsulations, we can see what areas of the system are responsible for responsiveness, extensibility, and accessibility. We can also gain insight into the broader system before it's even built. For example, we can start to see how a component's height is going to be the combined output of spacing, line height, and the text size of the component. Because of this, a component's height isn't something that we really can or should try to control directly. As designers, we like to define components by their height, but this shouldn't be a starting point. In order to support an adaptive system, component heights will be addressed as a system output, which we can try to target, but should not be a focus for as a specific value for or metric for design quality, success, because these could greatly vary depending on the viewport width, the density or the size options, and the user's preferred text size. Now that we know the system and its encapsulated parts, we need to start with the most basic elements and build our way up. This means that we are going to start with typography. And for typography, we're going to use a design approach that many of you may already be familiar with. We're going to start by defining a base font size and then create a modular scale to define all subsequent text sizes. In this case, we're going to start with 16 pixel base font size and a modular scale of 1 to 1.2. These two values will be used to generate every text size that we want to support in our typography system. We can write this as a function, such as text size equals the base times the ratio raised to the nth power. N, in this case, refers to the index of the text size that you're looking for. So for example, if we're going to look for the fourth larger text size in our scale, we would calculate 16 times 1.2 to the fourth power, which would give us the size of 33 pixels. Now, designers hate decimals and odd numbers, so we can very easily add a rounding function that ensures all of our values are whole, even numbers. With some rounding applied, we can make 33 a much prettier 34. This text size function is how we're going to start building our typography system. And again, if math and JavaScript isn't your thing, don't get too intimidated. At the end, I am going to share some tools that will take the math out of the equation. Pun intended. Okay, the next values that we want to choose for our type scale are going to depend on the viewport size. Since we want a responsive type scale, we're going to need to evaluate and define our type scales using multiple viewports. Between small, medium, large, and widescreen viewports, we may want to use different ratios. For example, 1.15, 1.2, 1.275, or 1.3. We may also want the base font size to be 14 pixels on smaller viewports and 20 pixels on widescreen viewports, and then 16 pixels on everything in between. Conditional ratios and base text sizes will help us to define a scalable and responsive typography system. This approach will make it easier to adjust our scales in the future, and we can build this using some basic conditional functions in JavaScript. When we implement this approach, we can see our entire type scale adapting to the viewport width, which results in a much more tailored approach to multi-surface typography. We can see here that the scale itself becomes more or less pronounced based on the available screen size, which provides us with the ability to use multiple levels of content hierarchy in our application without compromise. So let's take another look at our system diagram. So far, we have implemented a solution for responsive typography, but we still need to solve the overlapping problem for accessibility. Text sizes need to change based on the user's preferred text size, which means the user preference is going to need to alter our type scale too. The simplest way to do this is to make sure we convert all of our text sizes to rems instead of pixels. If you recall earlier, rems are basically a percentage of the base text size, which has a default of 16 pixels. So all we need to do is divide each text size by 16 in order to get that rem value. Now here's what that looks like in our demo app. I've added a slider here to help you change the default text size directly in the app. And this helps you to see how our type scale adapts to the user's preferred text size while also supporting responsive scaling. What's important to note here is that even though text sizes are changing across 2 dimensions, we're still able to uphold the visual hierarchy between each text size. This is because our entire typography system is defined on 2 specific values, the base size and the proportional ratio between all subsequent sizes. This approach of generating multiple text sizes using only 2 values is an exercise in parameterization. Parameterization is a powerful tool for systems-oriented design. It helps us to dynamically adjust scales or any other element based on their lowest common denominator. It's a design approach that scales design by its very nature. The constants, such as the viewport sizes that we want to target, the ratios and base sizes that we've defined for each, these are design parameters that we control as systems authors. At any time, we can change these parameters and alter the design of our entire system. The preferred text size and the user's viewport width are variable parameters, which are controlled by the end user and will adapt the system based on our design parameters to deliver a personalized product experience. Now that we've solved for basic typography using parametric design, it's time to take a look at spacing. Spacing in design is used to arrange elements and to create relationships and hierarchies. Objects closer together are seen as related, while objects further away are seen as unrelated. Looking at this example of text and an icon, we can see that the space between them is relatively small. This helps to signify to the user that these 2 elements are closely related. Now, if we shrink the icon and the text without adjusting the spacing between them, they ultimately lose their relationship. These 2 related things now seem much less related. What we're observing is that proximity or spatial relationships correlate with an object's size. So the distance between or around objects must be proportional to the elements themselves, otherwise we lose their intended relationships. Nearly every component of a design system consists of text and or an icon. Sometimes we use the icon with text, sometimes it's used in the place of text. But because of this, it's important that our spatial relationships are proportional to text size. This will give us a foundational relationship that we can rely on the rest of our system. And since we already have a type scale defined, we can leverage the type scale formula for our spacing scale too. By copying over the same formula, we can already be assured that our spacing values will be responsive and proportional to text. The key difference here is that we don't want our spacing values to change relative to the end user's preferred text size. The whole purpose of text scaling is to improve text legibility, not to just scale up an entire interface. So for our spacing scale, we're going to want to use pixels instead of rems. Now looking at our spacing values in the demo app, we can see these values change responsively. This pink stack of boxes are given heights for each of our spacing units. And you can notice as the screen size changes, so do the heights of each rectangle. This means that now we have a responsive and accessible type scale and a responsive spacing scale for our system. And believe it or not, that's the easy part. We still have to define spacing for our components and to support component size and density options. To do this, we need to find another systems-oriented design approach to help us. We're going to start by looking at our component ecosystem. This is an example of just some basic components found in most design systems. Some of the components you see here are going to be used in the demo app that I share at this talk. We need to support all of these different use cases for sizing and spacing. The best way for us to do this is by looking for commonalities across components. First, we can see that most of our simple components use the base font size for their text size. We can also see that many of these components have a gap between the text and some form of visual, whether it's an icon or a control, and they generally use the same spacing between them. Components with a physical boundary and the same text size have consistent vertical and horizontal paddings as well. We can use these use cases to create a basic archetype of our components. An archetype is the original pattern or model which all things of the same type are copied from. In our case, this will be basic components. This archetype is like a template for constructing any component in our system, and the archetype will also serve as a starting point for defining semantic tokens, as well as how we can support sizing and density options across the entire system. Now, for this talk, it is important that I define exactly what I mean by size and density before I go much further. Size relates to the overall size of an element, including its text size. So a badge is an example of a small component. Designers can select size options for any component's design in order to create content hierarchies. But density relates only to the internal spacing of a component. So a table cell, which may have larger padding than other components, could be considered as having lower density than the default. So even though its height may be larger than a default component, since it still uses the same default text size, it's not considered large. Instead, it's just the default size with a spacious density. Designers or consumers can use density options to increase or decrease the content density of an experience. Both size and density are separate dimensions of a component's scale, and defining them or differentiating between size and density in this way will help to ensure that content density does not affect content hierarchy. Now, coming back to our component archetype, we need to start by defining our default spacing. The way that we're going to do this is by specifying how many steps away from the base size a value should be along our spacing scale. For example, our base spacing size is 16 pixels, and we want to define a top and bottom padding of 6 pixels. So that would be 4 steps smaller on our spacing scale, or an index of -4. Similarly, if we want our left and right padding to be 12 pixels, which is 1 step smaller, that would be an index of -1. Expressing these padding values as indices relative to the base size will help us to calculate the spacing values we need. We can calculate the responsive spacing values for any component using our responsive base size, responsive ratios, and these relative indices that we've defined. This formulaic approach will ensure that our spacing values are proportional and responsive. And this is why it's important that we define the values in our archetype as relative indices, not as pixel values. This method can be easily scaled for generating differently sized components. Since the archetype spacing is defined using indices, we can also create an array for all other sizes that we want to create. So here I'm using an array of -1, 0, and 1. Negative being one size smaller, 0 being the base or the default, and +1 being one size larger. We use these values to increase or decrease the relative index for the padding. When we combine that with text sizes that also increase or decrease along the type scale, that gives us small, medium, and large components. This approach guarantees uniform and consistent proportions across differently sized components, which is important when creating content hierarchy in an interface. To define component densities, we take the same approach and add another dimension. A more compact density will decrease spacing values by 1 step, whereas a more comfortable or spacious density will increase spacing values by 1 step. So here we have 3 options: compact, regular, and comfortable, which are defined by another array of -1, 0, and 1. This is used to increase or decrease the spacing values alone. So by default, this will shift the value by 1 step, just as it does with sizing. But if we want to have a more pronounced difference between compact and spacious components, we can also define a density factor. So here, essentially, we're going to skip a value in the spacing scale, and that will mean we have a density factor of 2. That means compact components would have spacing indices that decrease by 2 steps, and spacious components would have values that increase in 2 steps. For a medium component, this means that a compact spacing would be 4 and 8 pixels, whereas a spacious component would have 10 and 20 pixel spacing. When we build this out into our demo app, we can see our arrays of t-shirt sized components and their density options. Since these use the responsive and accessible text sizes along with responsive spacing, we can see how our component designs adapt based on the viewport width and the user-defined text size. These archetype components can be used to help define semantic tokens and can be used as templates for designing or building all basic components of a product experience. This approach to finding commonalities across components to create a unified archetype or template is an exercise in abstraction. Abstractions are a systems-oriented method that will help component design scale. In other words, the system for sizing and density that we've defined is not confined to a single component alone. This can be used to design any component in our system and ensure that it's proportionally balanced, adaptive, and extensible. Now that we've solved for these encapsulated problems, we're going to revisit our system diagram and update it with some of the nuances that we've uncovered along the way. And this gives us a fuller picture of how text size and spacing values are created, what inputs affect those values, and how it relates to a component ecosystem. And this brings me to my last systems-oriented design method. Illustrating your system with diagrams will help to clarify relationships, encapsulate problems, and illuminate unforeseen challenges. These diagrams are helpful to systems designers, but they're also valuable for communicating and sharing complex ideas with others. System diagrams can be invaluable when identifying parameters of the system and solving multidimensional problems. Or should I say, when creating scalable scales that scale. So the system that I created today is an example of a complex systems problem, and I encourage you to visit the link to the demo app that I built for this talk. It's implemented using plain old JavaScript, CSS, and HTML, so it's a little more accessible. There's no framework knowledge required to look under the hood. But as you can see, you can toggle the density of the table component to see how end users can customize specific elements, or you can move the sliders at the top of the page to adapt the entire interface based on text scaling and browser zoom level. By resizing the browser viewport, text size, spacing, and component sizes adapt to the viewport. The purpose of this demo app is to provide a real-life example of what a dynamic system looks like and to encourage you to experiment with this on your own. Now, I recognize all of this can be pretty complex, and it is a challenge even to know where to begin with more systems design. For designers, current product design tools don't really do a great job of supporting systems design or systems-oriented design, but they are getting better every day. In the meantime, there are a few tools that I can share to help you get started. The first, which has been mentioned already, is called Proportio. I created this tool when trying to solve this exact problem for Intuit. It's a free open source web application for designing proportional typography, spacing, radius, elevation, and component systems using the methods that I shared today. It's a parametric design tool for experimentation. You can create basic primitive systems, spacing scales, and experiment with different ratios and see how they affect component design. The demo component is intended to act like an archetype or a template. Even though it looks like a button, it has wider scale use. Proportio lets you add small and large component options, change the default relative indices for padding, and add other density options like a unique density factor. It also generates design tokens as well as CSS variables that you can use in continued experimentation. You could import these tokens directly into Figma using an import plugin, or you could use the CSS directly in your system if that's all you need. If you're interested in fluid scaling systems, I recommend checking out utopia.fyi. This tool generates CSS clamp functions to generate fluid typography and spacing systems. Combined with Proportio, you could create an entirely fluid component system. So rather than resizing at each breakpoint, the text and spacing would resize fluidly and proportionally to every viewport width in between. The one caveat with this is that CSS clamp can have negative effects on accessibility that prevent users from scaling text, so you might want to investigate a little bit more before using it in your products. Oh yeah, and I should probably mention Token Studio. These folks are definitely thinking about the future of design and truly systematic design methodologies. If you saw the talks and demos earlier, you're aware of this. The nice thing about that graph engine is if you see the system diagrams that we're illustrating today, the graph engine is a more tangible expression of that system diagram that you can actually edit right then and there. So definitely check them out. Okay, so I hope that the methods I shared today will help you in your design systems work. Start by breaking down the problems, separate concerns, structure them into smaller encapsulated problems. Then identify the constants and the variables of your system. Find ways to define a simplified system based on how these interact. Parameterization like this will help you to create solutions that scale. Work in the abstract. Create generic, reusable templates to scale your design solutions across multiple use cases. And then put it all together in an illustrated diagram to help clarify and communicate the parts of your complex system and how they relate. All right. Thank you all for listening. I have some links that are shared in the Miro board today, but yeah, you can also follow me on all the socials. I like to write a lot on Medium. Happy to connect on Twitter and LinkedIn. So thank you.
Wow. Just wow. I hope you have a moment right now to look at this flood of hearts and claps that are coming. And a lot of the folks in the chat are like, it's day 3 of a conference and my brain feels like mush, but somehow I'm still paying attention and really want to follow along. So, thank you for making it so easy to understand and follow along. Certainly, a little bit more of a designer friendly way to follow some of the same complex concepts that we were showing in graph engines and other tools earlier in the conference. So, thank you so much for that. We do have some questions in the Miro board, and I'm sure right now the folks that were paying close attention are furiously going to add more. So if you don't mind, I'd love to tackle a few of them.
Sure.
Okay, let's start with some of the easier ones. How did you document such a component or a system that works like that? People are kind of wrapping their head around it. You mentioned creating system diagrams and things like that. So, what does that documentation look like, and how does it change between the kinds of audiences, between designers, developers, and stakeholders?
That's a good question. So we didn't get this completely fully implemented and delivered in our system at Intuit. So there's a lot of that we didn't get to sink our teeth into. But a lot of what I've kind of seen is with more complex systems like this, it's important to figure out what is really important to the end user that you're speaking with and what are the resources they need to do their job. So if you've got a team that really only works on mobile apps, they don't need to know about all this. They just need to know what the scale of all these components will be or should generally be on a mobile device, and vice versa. With our marketing teams, the designers on those teams were the most engaged in like some of these conversations because a lot of that responsiveness is something that they really wanted for landing pages and so forth. So for them, the communication is a little bit different. They're aware of how things are changing. They don't need to necessarily know the math, but you work with them to figure out what those proper proportions are um, as you move forward. But yeah, I wish I had a better answer
You
for
know,
you,
I
but
I think that's perfect. Like meet people where they are, give them the information they need, and you don't need to overly document everything to everybody, or they might feel a little overwhelmed. So I think that's amazing. Um, can you share what it was like to migrate to a scalable system from one that was not?
yeah, so we were still kind of getting there. There are challenges that you'll have to solve for along the way, like depending on your implementation or the platforms, are you delivering different token sets for each kind of breakpoint? Are you delivering functions to generate it within the system itself? Um, how you approach that really greatly depends on the platforms, the technologies that your products are building with. So that's kind of a challenge too, is to figure out which approach is the best fit for your products and implementation.
That's amazing. One final question before we give everybody a bit of a chance to let their brain settle before the very last talk of the conference. Someone was mentioning that when we think about scales for certain components, we might want to have different permutations, like maybe you want a different value for the top end of a typography scale than at the bottom end. How might you approach that?
I, I'm not sure I understand a different value for the top end versus the bottom end.
Like maybe you want your headlines to scale at a different multiplier than your paragraph text or something, I suppose.
Oh, yeah, no, that's a good question. So yeah, I've seen that like with headings are a big one where you can really make use of that responsiveness and you use different ratios for them. You might use a different type scale for paragraph and component text. It's also worth mentioning too, like if you're going on this approach, really consider what actually has to be responsive. One of the things that we did determine at Intuit was headings are something we definitely want responsive. So the responsive scale and base sizes, but paragraph text and components for our products did not make sense to have responsive as we were looking at it. So make sure that you're finding where to draw that line. Don't just go all in all at once. But yeah.
I That might be a key takeaway for me from the conference is not everything has to be responsive. A lot of people think it's all or nothing. So that's a great piece of advice that everyone can take away, even if you're not willing to dive into these math sorts of conversations right now. So thank you again so much for sharing this really valuable story with the community and everybody watching at home and in the future from these recordings. The links to the tools that Nate demonstrated in the talk, as well as the slides, are already available in the Miro board, in the Airtable. And I think Nate is going to spend some time going through some of the more specific and technical questions that are in the Miro board. I know Marco has a few that he was pretty excited to ask you as well on a very nerdy level. So I'm sure you guys will have lots to talk about. And thank you so much for your time. We really appreciate you. We're going to take about a 15-minute break to let everybody settle, and then we'll be back for the last talk.